Hey, so this video is going to be on second, third, fourth, that kind of thing, derivatives. We're just going to go through a couple of examples. I'm going to be using the notations of like f prime for instead of doing dy by dx, but I'm just going to show you a couple of notations to start with. We're just up to 3. So we have our dy by dx, and now there's another video on why this happens. Sorry, that's meant to be 2 there. There's another video on why this happens, but this is d squared y by dx squared. So notice how the 2's on the d and the 2's on the x. And for the 3, d cubed y dx cubed. As I say, there's another video on why this happens, but we'll just for now just take it, that's how it is. This is how it works. And also, when you might also see if you're going to have to the 4, you might see that, or you might see someone putting it in Roman numerals, because obviously if you had this to 7 or 8, it just gets a bit ridiculous. So you have like 1v. So just a quick bit on notation there for you before we start. So if I had a term here, and we're going to say f of x, we'll take a nice simple one first, is equal to, we'll do x to the 5 plus 2x cubed plus x squared minus 9. And what we're going to do is we're going to just differentiate this a few times. So we're just going to do f prime. We move our 5 down, x goes to 4 plus 6x squared plus 2x, and then our 9 disappears. So we know how to do that from our last videos. But what you can do is if you just do the second, you just apply all your same rules again. So you get 20x cubed plus 12x plus 2. And now we go again. Cubed, and we have 60x squared plus 12, our 2 disappears. One more time, we have 120x, and if we go for our 5th one here, we get 120. That's just how you differentiate going down. You just keep applying all your rules again, and it just keeps working every time. Just keep applying things. As you'll go through when we go some more of the rules, product rules and such, you'll see that can get quite complicated, because when you do the product rule you end up with quite a complicated term, or even the quotient rule, which is much worse, and then you have to apply these rules again and again and again, and it gets very complicated. But we'll go through one more example nice and quickly, and in fact we'll go through 2 more. So we'll do e to the x, this is our function. We'll try and save some room. We'll say our function equals this, and we'll say that then f prime, as we know, as you've had a look at tables of derivatives, is equal to e to the x, and f double prime is equal to e to the x, f triple prime is equal to e to the x, and so that just carries on. There's functions like that which will always stay the same. There's functions like one we just looked at which change. And we'll have a look at one last example then, which is we'll do our function of x. Again, if it's just f, it's just our function of x. We've already got that in there, it doesn't really matter. And we're going to say this is equal to sine x. Now, as you know, we take the derivative of sine x, so our first is prime, and this is equal to cos x. Our f double prime then is going to be equal, now cos x, remember that goes to minus sine x, so minus sine x. Our triple goes to minus cos x, and by the time we get back to number 4, we get minus sine x, which is plus sine x. Let's go back to sine x. That's another example of how these derivatives can go. They can recur. So then if you were going to take the 5th derivative, you can just look at our first here, our 6th, our 2nd, and you can see how it goes down there and it works. So derivatives can recur like that and have the same output again. And now we're going to move on to some rules. Remember, if you want to see the last video, the next video, or you want to see more from my channel, just click here.